All right, we're back. It's COMP125 in the summer 2018 semester at Centennial. And we are week 8, part 2 of our broadcast, talking about JavaScript OOP, object-oriented programming, and it's part 2 of that as well. We might do a part 3 and part 4, like I talked about. Again, this is a client-side web development class that we're doing at Centennial. And yesterday, just to or the last video, depending on what you're doing, we talked about properties of objects and so on. And I'm just going to bring up yesterday's exercise. So we reordered, just to review, we reordered our web application a little bit, just because I don't want to have many files. I only want one file this time around. And we're going to make it so that there he is. I'm going to make it so that we have that one file is going to eventually be a single page application. That's what I want to get to you with you guys, right? So a single page application means that it looks like it's multiple pages, but we're using one view, one page to inject. We're going to inject content in that one page to make it look like multiple pages. All right, so it's a different way of doing things. It's more modern. A lot of modern front-end frameworks do the same kind of idea, where they have one front end, they use one index.html, and they use Ajax, which we're going to get to inject content into the page. Ajax is asynchronous JavaScript, and XML is what it used to stand for. But I want you to think of Ajax as a way of accessing files asynchronously from the server, right? So I want to have all these files, I want to access them, and then I inject the data from the files into into our page. But I don't want to get there yet. Today, we're still talking about OOP, object-oriented programming. And yesterday, when we set up our scripts, just to review, everything was the same on our index.html page, pretty much. The only thing we did differently was I used Yarn to get the packages as opposed to NPM. And I recommend Yarn as a package manager to grab stuff from the web. If you're going to do development like the way we did it, I think it's the most modern way of doing it now. It used to be Bower. That was the other older way. There are other package managers as well, but I think Yarn is kind of the popular kid on the block right now, right? Maybe in 3 months it'll be something else, and that's how we roll with the web, right? Web development every 3 months, something else. So emerging technologies. When we talk about emerging technologies, web is an emerging technology. It keeps on emerging with new stuff, right, all the time. But let's go back to scripts. So we also put our script inside the core folder, and I did that from an organizational perspective. So I don't have to do it, but I did it because it kind of creates almost this phantom core module. We don't really have a core module yet, but I'm putting it inside this core folder. And usually what I do is I set up my folders as the module names. And actually the same way we do it with Java and also C#. C# we have a folder as an example. Let's say we have a folder called My Stuff, and we make a namespace called My Stuff. And the namespace or module, depending on how you look at it, right, usually uses the folder structure of the application, typically. Now, it doesn't have to. You can do it any way you like, but that's just a typical structure for, at least that's how I do it. So we also set up this, this stuff that we know and love so well. We use this IFI, and we've passed in this core object. Right now, the core object is really empty. And then we talked about how to set up an object, different ways of doing that. We talked about literal notation, which is just this, which I recommend for now. We also did the new, which is constructor notation. And we also did this other one called object.create null. And that was the 3 ways of setting up your object as an empty container. I want you to think about this as an empty container now. So you have a container, it doesn't contain anything, it's just empty. This is the most empty. You're going to get the most empty out of this notation, right? This way you're going to get a prototype that you're inheriting from. And remember that we always inherit in JavaScript, actually in C# and in Java, from the object root class or superclass, right? So the object class in Java and in C# is kind of similar. They've kind of modeled it the same way here, where it's the same thing. The object class is the superclass of all other classes that inherit from it. And we also talked about ways of defining properties. There's two ways that I've shown you so far. It's this way where we say, hey, I have my object, and then I have the property name, or these are two property. In this case, the property name is name, or the identifier is name, and the identifier for this one is age, right? So there's two identifiers for two properties, right? And this is one way of doing it, and it's a quick way, right? And we're like, okay, cool, that's all right. But what about this way? This is the more detailed way where we have more control, right? And when we talk about the property, each property can be configurable or enumerable, which means I can loop through it. I can add a value to it if I want to. I can make it writable or not writable, so I can make it read-only or not, right? And in this case, I created two what I like to call private properties. But just to let you guys know, there are no private properties in JavaScript. Everything in JavaScript is public, okay? There are no access modifiers officially in JavaScript right now.
But there are other ways to make them.
You could do it private by putting it inside of a closure, right? So you do it inside of a closure, then it's inside there, it can't escape, so effectively it's private, right?
Configuring something.
Right. And well, configuring property, you can make it read-only, but remember that right now, the way I've done it is it's all public. Even though I'm calling it private, it's not really private. I'm kind of modeling these two properties after the way we do things in C#. So you guys are more comfortable with it. That's all I'm doing. I'm not saying that it's the only way, the best way. And then, so I did these two, and then I did these two. These kind of like modeled after the public properties, right? And I have these two getters, a getter and setter. And these getters and setters, in fact, all of these are all optional. Everything in here inside this and these curly brackets, this configuration, it's all optional. If you leave it, they have defaults. And remember, we talked about that. If you go up online to our little files that I gave you for here, you can see that all of this has defaults. So I'm looking at the syntax for define property. And inside there, you can see that there's three things. The object, which is this one. The property name is normally a string. And then the descriptor object. And the descriptor can actually be separated into a separate object itself that you can configure and then add to the property if you really want to. So if you have, an example, if you had all the properties were very similar, you can create a descriptor property that you can, or object that you can use, a named object that you can use instead of making it the way I've done inline. So if you have a lot of properties that are very similar, right?
The descriptor, it seems to be like a set of attributes.
It's an attribute, but notice it's in object notation. Well, curly brace, that means object, right? Whenever I see curly brace in my mind in JavaScript, object, right? So I'm using object notation to define my object, which is sometimes confusing because you're like, hey, wait a minute, I'm defining an object, but I'm using an object to define it, right? So, and there's some examples down here on how to do that, but notice that all these values have defaults. Where it says defaults to, that means if they can be ignored or omitted. And going back to our quick way of doing things up here, that's what this does. It sets up the defaults. Whatever I said here, it's the defaults. Okay? So that's what this thing does. And we spent a lot of time doing this define property stuff because I want you to understand the back end, of kind of what's happening automatically for you. Okay? There's other ones here, by the way. And we can't get to all of them, unfortunately. There's just no time to get to all of these things that the object does for us, right? But we're going to get to some of the key ones, and then I'm going to allow you, you're going to go on and explore on your own, I'm hoping. But there's some really good ones we're going to talk about. I'm going to try and, hit them again at some other point throughout the time. And it's the challenge for us to try and get as much of this, kind of explained to you as possible. But some of these examples are pretty good. We also talked about the book that I recommend. There is this set of books that I talked about yesterday called You Don't Know JS, which is kind of online to some degree. Again, I'm not sure if this is a free one or whatever, but there is similar examples in here in the book where they talk about the prototypes in detail. So both those two resources, I think, are really good resources to look at to understand properties of objects. Later on, when you do other more advanced JavaScript, you may need to go and look at these things again, refer to them, because you're going to forget. You're going to forget. That happens when you pick up another language. You're going to be going back to C# next semester, and then maybe another semester, and then finally back to JavaScript again. And it's going to be 2 semesters before you see JavaScript again, potentially. so that it's going to be like a bit of a break, and your mind is going to somehow disconnect from all of it. And that's what happens. So we talked about those things yesterday, and now today I want to talk about how to, kind of, we've got this part, and these are just like properties. I'm just going to kind of comment all this out because I want to help you with your lab today. All right, so the lab this is examples. I'm going to leave the examples in this particular commit, right? And then I'm going to wipe them out in the next commit. Now, the great thing about using GitHub is if you ever go back to the previous commit, you see all the examples. Even though the comments are wiped away here, in the previous commit, it'll show all the stuff that's there anyway. If you go back to the previous commit up on GitHub, and you can see all these examples up online. All right, so I'm commenting all this out. So now I have an empty object, but wouldn't it be nice if I had this empty object in a separate file, okay? Which is where we want to go. I know that you guys are, oh God, not a separate file again. But really, this is where we want to go. So we have my object. This is one way of doing it. But I want to show you another way. I want to use constructor notation today. Okay, so we've done it this way. I'm going to comment this out. I have my object. And here's my object here, as an example. But you can also, create a constructor by using a constructor notation. I'm going to kind of look at this in this. I'm going to comment this out for a second. Okay, so my object. And the way to do that is I would probably do it like a class. I'm going to start constructing a class now. Okay, so going down to this part right here, this is not going to work anymore right now, and none of this is going to work. So I'm going to just like get rid of it for now because we're going to use something else. Okay, in main. I'm going to save this, and I'm going to go to my GitHub. So you're going to see all this right now. Actually, let me undo that. Change. And I'll just comment that out too. You'll see what I want, why I'm talking about this. And I'm going to say, comment it out. Example from day one, right? That's what this is. And I'm going to add this in here using GitHub. And when I press this check mark, and I go to Git and push, you're going to have all these comments commented out on GitHub, which is what I want. It's a recording, almost a log of what we're doing, right? Now what I can do is I can just remove them all just to clean up my file a little bit because you have it all. And to show you this, by the way, if you look at GitHub and you're like, hey, wait a minute, what are you talking about, Tom? How can I look back? Well, if you look at GitHub and if you look at my files, Centennial. If you look at the files that I'm sharing with you, this is lesson 8, right? And if you look at the commits, you can see that here's what I did from day 1. And if I actually click on that commit, you can see all the stuff right here. Right? You can see them all, right? So even though this is what it was, now it's this, and it tells you the additions and changes. That's what it's doing, right? So that's GitHub. So you can always look back. That's the idea, and you have examples of it. And plus, it's recorded, so you can always go back and go, hey, yeah, it's recorded online. So I can always go back and look at that. But I want to clean this up for a couple of reasons. One of them is I don't need all this stuff, and I also want to really do it the way I would like. So we're going to do it inline right now in the same file, and eventually we're going to split it off into multiple files, which is where we want to go. All right, because that's how we do classes in real life. With JavaScript and C# and Java and every language you do it. You do a class in a different file, right? You don't do it in the same file because it's too much to look at. Like even now, it's a lot, right? And I only have 2 functions, and you have to scroll down. And too much scrolling means you can make mistakes, right?
Do we have some
No. Forget the tool. The tool is you. In fact, most people don't even want to use Visual Studio Code.
Visual Studio, which helps.
Visual Studio Code is okay. Visual Studio, if you like Visual Studio, use Visual Studio. But the thing with Visual Studio is we don't do JavaScript with Visual Studio typically. We use Visual Studio Code, Atom, WebStorm, other things. Visual Studio is mostly for .NET if we're going to do web stuff, and for C++, C#, not Java. We don't do Java and C in Visual Studio. We use IntelliJ IDEA or NetBeans or something else. There's not one size fits all for an editor. You have to pick the right tool for the job, right? Just like if you're a plumber, right? You're not going to have like one wrench to do every pipe, right? I don't know if that's a great analogy, but that's how it is. It's not the same tool. We're going to use different tools. So all this stuff that we have in our core functionality is good, but I want to talk about constructor notation for a second. So there's two ways to do it. If I want to do it in the local space, as an example, I don't have any app variables yet. I want to use a function. I want you to think of it like this, right? And let's suppose my function is called my object now. So here's my object as a function, right? And my function object, right, also takes parameters. So let's say, for example, I want to take my name and an age as a parameter, right? And then here's what constructor notation looks like. You use the this keyword, and then whatever you want to attach. Remember, once we assign the variable, it exists in JavaScript from an object perspective. So let's say, for example, I want to have my private variable, which is underscore name is equal to name, and this dot underscore age is equal to age. I did this, right? This is an example of constructor notation. So now, if I was to do this, and down inside my main, as an example, and by the way, I don't have to do it up here like this,
But you didn't
right?
specify this the properties of it.
Nope. I'm just doing it the quick way. I showed you the properties yesterday so that you understand the back end and what's going on. And we'll talk more about that later on. But remember, I have a limited time too. If I was going to go all the properties today, we wouldn't finish. So yeah, that was just an example yesterday. So inside my main, as an example, I want to use it as my constructor. I could do something like this. I could say, well, let now my person is equal to a new my object. I can use the new keyword, and then look, it passes in age and name. It asks me for age and name, right? In thing, this is just like we normally used to. We used to seeing this in C# and Java, this kind of notation, and where I can pass in the name and age, and that's it, right? And if I was to console log that, so I'll say console log person, right? And let's just show you what that looks like. So I'm going to go to open a command prompt like we normally do. And down here, I'm going to say light server. Let's see what that looks like. So I'm going to go into inspect, and we're going to go into console. And you can see now that I have my object that comes up. Take a look. And it says 49 and Tom. It doesn't say, it does not say, did I do something wrong? I did not do something wrong. Just make sure that I did it right. It does not say person or thing. It's of type my object. It doesn't say person. It says my object, right? And if I open it up, you can see that it has age and name, and both those two properties with an underscore in my books means I want to use it as a private property. There's no private property in this case, right? 49 and Tom, you can see that. Plus, I have a prototype object. You can see that there's a proto object, right? And the prototype is there's also a prototype in the prototype. Here's my constructor. My constructor is my object. That's the prototype. The prototype means what's the superclass? When you see underscore proto underscore, that right there, that notation means superclass. In your mind, when you look at it, or think about the base class, depending on the words that you've been taught in C# or Java, it's either called base class, superclass, root class, whatever, right? Parent class, right? But this proto underscore proto, right here, this signifies the root or base or parent class of this object right here, my object, okay? And so you can see that it's a constructor that takes a name and an age. That's what it says. And then here's the caller. Length is 2. So that means that there are 2 properties inside of the this class that I'm making. It's not really a class. It's a constructor for the object. I have an object using constructor notation. There's no class. Okay, don't think about the classes. Don't exist in JavaScript. Not really, right?
Why do the words say arguments?
Because there's other arguments. With all the configuration arguments, I can configure the constructor as well. So let's leave that alone. So if I go to the prototype, notice here's my constructor, my prototype for the constructor right here. And you can see that my prototype is called my object, name, age. And then down in here, you have your prototype, which is the object superclass. So the object superclass is the root class of my constructor, which is the root class of my person. That's how it goes, right? Because it goes to superclass of a superclass. So I'm using inheritance here, kind of. I'm inheriting from my object superclass, and I'm using it from my object when I use a constructor. So when I created my constructor notation, I did a lot of things all together at once. It happens immediately. Yes?
Can we explicitly inherit as in substance?
Yes, we'll do that in a second. We can't explicitly inherit. So let's go back. So this little thing up here, my object is kind of like a class. And it says that this construction function may be converted to a class declaration. Okay, I'm not going to do that yet. And the reason why this comes up, by the way, is because Visual Studio Code, with all the extras that I put in, is looking at it and going, hey, this could be a class. Yeah.
And do we have to use the function to create a constructor?
Yes. Because remember that in JavaScript, I know it's ugly. By the way, I'm showing you the old way. I'm going to show you the new way, and you may like the new way better. Similar things are happening in the new way, but I need to get you to understand the old way, because the new way on the back end is the old way. Right? So you don't know what's happening. It's like, I don't know, I'm doing stuff in the, you know, kind of in the background, and you have no idea what I'm doing, but you're just accepting what's happening. And I don't want you to do that with JavaScript, because you may think something is happening when something else is happening. You might think, well, okay, if I use the keyword class and I create an object for my class, then I think that it's just like Java or C#, and it's not. It's a prototype. Okay. So you have to understand prototypes. We have to make one. All right. So this is cool, right? Function my object or whatever. But how the heck do I add stuff to it, right? So this is one way of doing it with my constructor. And by the way, here's a good example of properties that are, I'm creating public properties here, right? Because my object, see my object right here? It's kind of out in the open. It's like exposed. I've got an exposed class constructor or object constructor. That's what this really is. And I have access to my name and age. Like if I was to expose my object, now this is the great thing about having this core module type thing. If I go down to the bottom and if I say, well, core.myObject is equal to my object, right? If I was to do that, and if I go back to console, right? And if I do core.myObject, right? Now we're supposed to see it, right? Because my object should be available to me, right? So there, notice that if I did this, it says undefined. How come? Because, did I spell it right? Yeah. Here it is up here. And sometimes notice that my window add event listener happens here, and I'm loading up my object, my start, and start happens when it loads, right? What happened to my object? There's another way we can do this as well. Remember, there's two ways of defining a function. To help us out, I just did it the way that we're used to seeing it, right? But here's the way that, this is why it's better sometimes to separate the function as an anonymous function from the name in JavaScript. So I can say let my object again, right? Hear me out. And then instead of doing it this way, I can make this anonymous, right? And then I can say that I can take this whole piece out, right? So here's my object. And inside my start, where we do our initialization, like we've done before, I can say something like, well, my object, right, is equal to bang, right? I can do that. And this is exactly the same as if I did it out here, but now it's inside my start method. So this stuff in here is still out there, right? Still the same. Here's my object. But now I'm going to get a weird error when I do this. Okay? I'm just pointing it out. So you can see this. When I do this before, when I had my function in the local space, that was fine. But when I do this now, I may not get the same result. So what I mean by that is if I go core and if I press enter, and if I look at this, I'm going to get nothing. I don't even get this part. Now, I'm not getting this part because it's after window.addEventListener. If I take this and put it before window.addEventListener, like up here, because this addEventListener kind of overrides what I'm doing here, right? And in fact, if anything, this is weird, right? I'm going to go back to this in a second. If I do this, and if I go core again, you're going to say, where is it? Where's my event? Where's my object? I want to see my object, and it's not there again. How come? By the way, you're going to get this in our first file, right? Well, because I never get to it. Because this works out to be, an event handler is asynchronous. So what's happening is it's loading up the start method, and it's going to ignore this part. And right now, my object is undefined anyway, right? Because my object up here is nothing, right? And it only really gets defined here. If I took this back out again, just to give you an example, let's try this again, and let's put this back up here, all right? So here's what you might see as well. Let my object is equal to function, where I decouple, right, my identifier from the function. This is just decoupled, okay? I'm not using a name function. I'm using my variable to point to a function that is anonymous, right? Still the same functionality-wise, all right? So I did this. I go back down here to core my object, and you're going to say, hey, where's my object? I can do this before, right? And how come it's not working now? And if I go back, and if I go to core, I press enter, you're going to see that, again, it's empty. How come? Because this is being overwritten, because I'm going to start at my start. Here's my start. I come to here, and it does nothing. It goes to main, follow the pattern, and it goes here, and I do this. That's all it does. And there's nothing, this is ignored, anything that's out here. So how do I conquer this? Well, I could say something like this. If I wanted to share into the core namespace, if I wanted to do this, then I would say something like, and this is weird, core.myObject, right? I know, it's weird. It's really weird, right? If I take this out and I put it inside my start function, before I get to main, I put it in here, and I say core.myObject is equal function. Now we're going to have another error. And just bear with me while I talk about this, because we're going to be talking about how, remember, we're putting a function within a function, totally fine. We can do that in JavaScript, no problem. We've seen that before. But now something weird's happening, right? And by the way, we don't need the semicolon anymore, because although it puts it in there for us. And if I go back, I get this. This is my object is not defined. Okay, so core, my object, don't know what that is. My object's not defined. I don't know what my object is. It's a problem. I can't do this, right? Even though you want to think to yourself, well, yeah, you should be able to do it, because I'm defining it and I'm assigning it to core because core is just an object right now, just like we normally did before with our other stuff. Remember, we had our other module. We did the same thing, but somehow not working. And it's not working because even though we're passing in the core thing in here, it says that it's a number. If I look through here, it says core is a number. How is core a number? I never defined it as a number. I didn't say anything about core. Even if I came up here and made it, okay, core is not a number anymore. Core is an object, right? As an example. I can do that up here too, right? You can do whatever you like. And if I go back, I'm still going to get this error, which is like my object is not defined. And it's all to do with this event listener. The event listener, what happens is in this structure, because it's attached directly to my index.html for the core module, the main module that attaches to it, you're going to have this funky stuff. And there's ways around that that we're going to get to, but not today. But I wanted to point this out, that attaching something to the core module right now, even though it is a module, notice that now if I look at this, it still says it's a number. Right? Function core, right? Remember, this is exactly the module or module notation we do in other modules, but here, nah, doesn't work because of that whole window add event listener thing, and because it's attached directly to our index.html. So just to keep in mind that this is what's happening. But I could do the other way around, which was what I showed you. So I could do let my object here, so define my variable, and decouple it from here, where I can do this notation. My object is a function, and this is the constructor notation. So here's constructor notation, right, to declare an object. I can spell declare. Not terrible spelling, as you can see, or typing, one of the two. And then down in here, I can still do this, and this totally works. And if you look back now, you can see that that is OK, right? Just like we did before. But you can see now that the prototype is object. If I go in there, you can see the constructor is this. Here's the constructor, and where I have name. And notice that my name for the constructor is my object. My caller is null, length is 2, but it's different. It looks a lot different. It doesn't have the constructor for that we used before, right? So this works totally. But because we didn't declare my object as a constructor from the beginning, as an example, we did it as just as a variable. If I hover over this, it just says any. We don't know what it is. Even though we did it here in my my start, and we can do this, no problem, and it will work just like we expect it to work. It's not the same. Yeah, I'm just pointing this out so you guys can understand. Okay, so look at the difference. Here, object, right? The prototype is an object. Okay, if I take this out again, guys, please pay attention to this. This is pretty important to understand because it'll screw you up later on when you think one thing's happening and something else is happening. But if I did this out here, and if I go back, now, even though the prototype is an object, this is my object, right? And if I go here into my constructor, you can see that it looks a little different, okay? It's almost identical, but there is some stuff that's happening that's slightly different, and this is the key, where my proto, and then I have another proto too that's an object, okay? So either way, I'm fine with either functionality because we don't care if the object is empty or has my object as a constructor. But this is just the constructor notation. Let's just put it back the way it was, decoupled, because it's fine. Okay, there's decoupled again. It's undoing. Okay, so great. I got some properties, and I want to add some. I want to add a method. How do I add a method to this thing? Because now it's kind of like a class, but not. It's a prototype, right? How do I add a method to this thing? Well, we use the object to do that. So again, if you go back to the documentation, and if you look at the, go all the way to the top, and if you look at object.prototype, right? So here's object.prototype. You can do things like has own property. Does it exist? Has own property, basically what it does is it says, I can check to see if a property exists. It'll return true or false. If I name the property, and I want to check to see if that property exists in the object. Okay, so that's what has own property does. Can't go too much further than this, guys, because I'm kind of rushing to get everything else that I want to get done today, right? So that's what that does. And you can also do other things that that's part of you know, the object itself. I can take my prototype toString and so on. But what I really want to do is I want to use the prototype of the function, my object, and attach, right, a method, a named method. And there's a couple ways to do that. One way would be, you would think, is my object dot prototype. Call the prototype on my object. My object is an object, right? We just called it my object. I'm going to rename it in later on. We'll call it person. My object dot prototype dot the name of that you want to assign the method as an example. So let's say my method is going to be called says hello, right? And then I attach it to a function, like normal, right? So basically what this is saying is, hey, my says hello method is this function. Okay, let's just try this and see what happens. Okay, so I do this, and you see that there's nothing in it, and I go back to here, and what do I see now? I see that I have age and name and nothing else. I'm just putting it out there so you see that there's not much going on right now. All right, so cool. So my object.prototype says hello is equal to function. But what if I actually do something with this? If I say something like a console log, so a console log, right? And the function is going to use backtick. You know, I'm going to say that I want to do the property that I want to access, which is this dot. And notice it comes up. It detects the two properties as I'm typing the template string. I can say that this dot underscore name, right, says hello, which is what we're going to be doing today. This is part of your lab. Okay, so there's my console log. Yay. Okay, that's my that's how you define a method. So method definition or declaration, let's say. It's kind of declaring it and defining it at the same time. In C# you can, or sorry, in C++ you can separate those, right? You have an H class, a .h, and you also have a .cpp. And the .h, basically what it does is it uses almost like an interface. It creates an interface for you that declares all your functions. And then what you do is you define them later. Here we do declaration and definition in one, which is what you do in C# too, in Java, right? So say my function says hello. This is just the funky syntax to do it. My object prototype. My object prototype, which is ugly, right? You're like, hey, that's really ugly, right? What does this mean, my object prototype? It means, hey, go to my object, use the prototype, attach to the prototype, says hello. And what is says hello? Well, it equals to this. It equals to a function. And this function now is going to be a method, right? That's attached to this my object. Right? That's what it is. Okay, cool. Well, how do I use it? Just like normal. So I'm going to go down in here, and now that my person is my object, is an object, right? I can say that person dot says hello, right? I can do that. Let's see if it works, right? So person dot says hello, Tom says hello, right? That worked. But if you look at my object now, you still only see these two things. Hey, I'm just pointing it out to you guys so you understand what I'm talking about here, right? I only have these two properties. I don't see the other stuff. But look, here's in the prototype, I see this says hello method. Here it is right here. I've attached to the prototype because the person object is inheriting from my object prototype, which I've just created, right? And what's happening is that's how it works. I'm using best way to say it is I'm using the object prototype, my object prototype, and my object has a function that says hello. And if I look at it from what this function is, if I kind of dig into it to try and find out, there's a prototype which has a constructor, and inside the constructor, if I keep going into it, right, you can keep on going down the rabbit hole, as you can see. Look, keep going as a function within a function until it looks like it's going on forever, right? It's not really true. It's just you have to know when to stop. So says hello is a function. That's what we know. It doesn't give us the details right now. We know it takes no arguments. That's what we know here. Function that takes no arguments. That's what the F stands for, right? But if I hover over it on Chrome, it tells you what the function does. It's a function that has console log. This name says hello. It says it right there, right? If you notice that when I hover over it. Okay. Again, notice that the prototype is a function prototype. That's what it is. And the prototype of the prototype, so the constructor is a function, and the prototype for this function says hello is the object, because all functions in C# in JavaScript, sorry, are objects. When I make a function, I'm actually making an object. And we've been talking about this kind of, I've been skimming the surface and kind of beating around the bush all semester about this, but that's what it really is. All functions are objects. And if all functions are objects, that means they have a constructor, and they have properties, and they have all that kind of stuff, right? And that's why it looks like there's a rabbit hole here. It looks like I can keep digging in and going to the property of the constructor and keep going down into the rabbit hole. But at the end of the day, there is this function location, which is app.js line 23, where I define it. Inside scopes, it talks about the scope. You can actually look at it. It says type closure, name is core. That's the core, the closure that I'm inside. Here's my script, right? It's inside the script file, and it's in the global namespace. Here's my globals. You can see all the globals right here. And all this is available nicely on your console window. A little bit confusing at times, but this is the key thing. That says hello is attached to this object, because says hello is a method, just like we would normally make it in C# a method. We would define it on one. But it looks decoupled for us. It looks decoupled. Okay, let's use let's separate this. And I want to put this this function, this my object, I want to call it person, and I want to put it inside of its own person class. Okay? In fact, if I rename this, if I said that instead of my object, let's call it person. So in Visual Studio Code, you can right-click and do rename symbol. And if I rename symbol as person with a capital P, then everything is renamed. So it says person.prototype says hello, just so that we know what it is. And now you can see that let person lowercase is equal to a new capital person, which is the class, right? So this is object creation, also called instantiation. Instantiation, yeah, there we go.
So in JavaScript, you don't need to define the structure. Straight away initialize it.
Well, I'm doing it right here. Look, here's the structure. Here's my constructor, and here's my method. That's the structure, right? And the constructor also includes properties right here, right? Okay, but this is all out in the open, and I want to kind of do this. Let me put this up. So I'm going to say, I'm going to put this up on GitHub. So you have this version on GitHub. So I'm going to go here and say, created JavaScript constructor. You see which one that is, and I'll add that in. Click onto it. And again, this is very basic, guys. We're going to get to the more complex way of doing it. Here's a hint. If you forget how to do it, you have tools that can help you, right? So if you're concerned about doing this on your own and you forgot the notation, you're like, I can't remember that prototype keyword. What do I do to add a method again? Here's what you can do. Remember TypeScript? TypeScript has this playground, right? Here's the playground on TypeScript. I talked about this before. I can, let's just get rid of all that. I can define my class with the class keyword, right? So normally what we would do in the modern JS, we say class, person, right? As an example, inside the person, we have a constructor, right? By the way, I'm teaching you how to do constructor notation and everything else in modern JS. This is the way you do it. So please pay attention. It's exactly the same. There's no difference here between TypeScript and ES6 in this case, what I'm showing you. All right, and then we have a name and an age in the constructor. As an example, we can say this dot underscore name is equal to name, and this dot underscore age is equal to age. The only difference in TypeScript is you have to define the member variables. So I can say something like this dot. So I'll say underscore name is of type string, and underscore age is of type number. Notice on the right, this is the notation that we need, right? All right, here's something. So I've got all this, and if I make these private, like we want to make these private, as an example, it doesn't do anything to this. There's no private, public, doesn't matter in Java. It's all public. It's all public, no matter what you do, unless you hide it, right? Notice that what I've done here is something funny, right? What JavaScript is asking you to do to create a proper class is the following. It says, hey, make person be an iffy. That's what it's asking you to do. This is the right thing to do. So person is now an iffy, okay? Closure. Now you can save things from escaping from the closure, huh? This? All right. This is just it right here. This is, if you notice what's on this side, it's this, right? It just converts it right away, right? So this person is an iffy. This is what the iffy is right here. And in the iffy, we have another constructor, which is what we normally see in C# in Java, with the exact same name as the class. Here's the constructor, and the constructor has the same name as the class. And by the way, this is just miming what C# and what Java and other object-oriented languages do, classical inheritance, right? And now I have a return. Okay, so what the heck does this mean? I'm actually returning this person. So I'm returning person out of the constructor, right? So when I, and this is inside this function, right? So the function actually returns this object, this constructor. That's what it does right now, okay? And it returns it to the person object. This is the person object, right? Okay, now let's add in a method. So let's say normally we'd have a method. Maybe we want to make this public or private as an example. And we write public in TypeScript. And we call the method says hello, right? And let's say it returns void. You can actually put as much or little stuff as you want in here. Even if I avoid that, it doesn't do anything. On the right, it doesn't change anything. But look what it does. It does exactly what we did. Person.prototype.saysHello is equal to function. Exactly the same, right? There's no difference between what I've done here and what's happening here. The only thing is that these two things now are inside of a closure, right? Which is what we didn't have before. All right, so let's continue, please. So we're going to try this out. So then we'll do the same thing. We'll say console log, right, and backtick, and then we can use the $, and then we'll say this._name, right, as an example. And then says hello. Take a look at the right, please. Right? What does it say? It's exactly the same as what we had. Exactly. There's no difference between these two things and what I did. The only difference is that we have this closure around it. So, quick way, if you forgot how to do it. I'm telling you on a test or whatever. Take this, copy it, go back to here, right? And inside here, right, notice I have my function in my prototype. I don't have to put it in my function, my prototype in here. Let's say now I take this whole thing, kind of cut this out, and I don't need this anymore. And there's two ways I can do it. I can put it inside of my core, right, by doing this. Copy. And we'll change the var to a let just for us. Can I do this? Can I put a iffy inside of an iffy? Will this ever trigger? Can I ever use it? Well, let's see. And it says class, but don't worry about this. Let's just get rid of this just so it looks normal. And this, my friends, is the person class. The person class has two properties, name and age, right? And it has a method called saysHello. That's the method, right? And it's actually creating an iffy. Here's the iffy right here, a closure, right? And here, this person is returning the constructor, and we're attaching to the constructor the saysHello method, right? So when I return it outside of this closure, person now equals to person. This person outside is equal to this person inside. Okay? Let's keep going so you understand what I'm talking about. Now, down and over here, where I say let person is equal to person, it says person is now type of person. It's a different thing. And you're going to see it actually responds differently. It's actually going to show up differently because of this extra closure that we put together. Let's see what this does. So I do this, and I go back out to this, and now we have a different thing. It doesn't say my object anymore. It says person, yeah?
Can we use the TypeScript code itself?
No. We have to transpile, remember? Transpile with Babel. And we're going to use another transpiler later on in the course. Don't use TypeScript right now. I'm just using TypeScript as an example to write clean code and then convert it to JavaScript. So you have an idea of what to do if you forgot. All right, it's the same thing, right? And notice I have my prototype. If I go in there, it says hello, exactly the same thing. So the only difference is that my constructor is the person constructor. It's the name is person. And I have this saysHello prototype that's attached to it. Look, saysHello, which is different. Right? Here it is. And that we didn't have before. All right, it's like kind of going down in two levels, right? Notice the scope says 3 before he says scopes 2. Why? Because we have the outer scope, which is the closure, the iffy. And then inside we have that function. And it looks weird because really what we're doing is here's a function. There's a function inside of this, and there's a function inside of that. Function and a function and a function. And so we get to this idea of function hell. Right? We're like, hey, this looks like really hellish. Why? It's really ugly notation. Why was it done this way? Because JavaScript was written to be quick and flexible and all this kind of stuff. And you know, we want to be able to inherit from person. And how do we do this? We'll get to that in a sec. Are we clear about this part though? Person is equal to function. Cool. I'm returning person. No problem. Okay. And now my person is equal to this whole thing. I'm good with that, right? And when I have this return statement, this return statement belongs to this function, the iffy itself. Remember we talked about that? I can actually do that here. So this iffy, I can also return something if I really want to. I can say that, well, I don't know, it's going to be ignored. But let's say if I return something out, if I say return 0, right? I don't know why. Just I want to return 0, a number, right? If I want to do that. What happens to this core thing? Remember we have core, and core is being passed in here. And then this whole thing, I'm returning 0. What the heck? What is core anyway? And if I go back out and I click core and I press enter, you still got nothing. Doesn't matter. It's being ignored, right? Unless I don't do this, right? Unless I did what we're doing, right? And I want to kind of attach an object, not necessarily a module, a core module, but if I took this away, and if I put an equal sign here, right? I'm just splitting it across 2 lines, right? And I took this away. Well, actually, it doesn't really matter what I do here, but let me just take this away. I'll put it back in a second. I take this away, right? And notice I have this extra stuff out here, right? So this is the closure that I have. Here's my function. My function is equal to core. And now I don't have a closure anymore. I'm returning 0. And if I go back out, and if I go to here and I put core, no difference, but if I put core, core is now 0. Because I'm returning core, I'm returning 0 to core. Core, the actual value of core itself, this thing here. And if I open this up to see what the heck this is, you can see that there is nothing. It's not an object anymore, it's just 0. However, if I return an object, which I can do too, I can return an object, an empty object, right? And you can see that now. If I go core is now an object like before, right? I did this. I'm showing other ways of doing things, same things, right? And then in my object, it can have 2 properties, right? I can have a person property, person, which is person, right? Person, now this person doesn't exist because my person is this, right? See that? This person here. And if it says here, person, this person is type of person, the person class. This person is the property of core. This person here is the property of what I'm returning. And if you notice, if I hover over it, it says property. This is not property. This is this. I'm making a reference to the class. I'm actually returning out the class person. That's what I'm doing. And if I go back out and I go to here and I type core, now you can see that I have person as something that I'm returning. And person is a class. And now if I did this, I can do something like this. I can say that let person is equal to a new core.person, where I pass in my name, Mike, and my age, 50. And then if I say person.saysHello, it should say Mike says hello. And I can do that on the console because I'm passing out person. I'm exposing person outside of my class by using a return statement. Okay? Whew. Now, if you don't understand that, it's okay, right? But the idea here is that the return, what it allows me to do is expose anything I want from the iffy. The iffy itself is a closure, and then I can return anything I want out of the closure. Because then the iffy itself, especially if I make it equal something like I just did, which is this notation, let core equal to, as opposed to I'm creating a module. And this, my friends, works okay. This works okay because now I'm not passing anything into the function because the function itself is being automatically called when I attach it to the index.html file. And because I'm waiting for the listener to load, this works better for us in the core module. Okay? And I can attach anything else out that I want. If I have other properties up here, let's say, for example, I have inside my app variables, I have some other variables like let, I don't know, my number equal to 5, right? And it's nothing right now. I don't use it, but I want to return that too. I can kind of come down in here and say, comma, here's my list of properties and my objects. You know, my number, right, is equal to my number, right? I'm just attaching my number. Oh, no semicolon because it's a list. right? And if I go back out to here now, and if I go to core and I press enter, I have both person and my number. And you can see now that that is my person class and my number variable. And let's take it one more step further. So you see the difference? So I can do this, my number. I can also do a function. Let's do start here, because I can actually point to start too. I can say that, or main. Let's do main. So I actually do both. Let's do both. So I'll say that here. So I can say that start is equal to start. I can expose that, and main is equal to main. There we go. So now I've exposed everything: person, my number, start, and main. And if I do this, and I go back out, and I go here, and if it's core, you can see it's all there. And now we have functions, main and start, as well as a class, person, right? And if I look at the differences, do they look different? Here's the main function. Looks like it's got a prototype. Looks like it's got a superclass, and so on. And here's person, side by side, right? Looks similar, but look, there's a name. It's a constructor. It looks like there's two properties, name and age. And that's interesting. And I have a prototype, which also includes says hello, right? And I can go start, and start looks like the name start. The constructor is no, I don't have any properties in the constructor for my start. And now because they're exposed out here, I could always go core.start. I can call it from out here, right? Because I've exposed it, right? If I expose something, I can access it outside of my closure, right? And it's all inside of my core object. Different than what I've done before, okay? But we don't want this. We use this as a way of enclosing our files. If I want to return anything, I'm probably going to return the person class, because that makes sense, because the person class would be inside of my closure. But guess what we're going to do? We're going to take that person class and put it in its own file, which is next. So let's just get this out and get back to what we had before. And in fact, because we're not even returning anything, let's just not even do this at all. And that's what I'm saying, because I wanted to show you just so that in your mind, you're like, why don't we ever make a named thing that we have a module that we can return stuff? And it kind of doesn't work in the way we did it in the other areas. So I want to kind of take this let person class, and we kind of set up modules before. But what if, and I want you guys to tell me now, I need you to tell me what's going to happen here, okay? So here's what I want to do. I want to make a new file, and I want to put it somewhere else. And I want to put it inside another folder called objects, because now my person is an object, right? It's going to be a bunch of objects, let's say or classes that I use for my my web application. I have a bunch of web classes, a bunch of stuff that I want to use, a library of classes, let's say. We're just going to call it objects. I'm going to put all my object classes in one folder for now, right? So I'm going to right-click on scripts. I'm going to make a new folder. I'm going to call this folder objects. Okay, so here's my object folder, right? I want to make a new file. And I'm going to call this person. My person.js file, okay? And I want to take my person class that I have, that I determined here, cut it out of here. I want to cut this out completely, the way it is, as is. I want to cut it out, and I'm going to put it here. Okay. Would it be okay? Can I do this? Yeah, of course, because I just put some code, some JavaScript in another file. Inside my app.js, I don't need this anymore. Inside my app.js now, all I have is me utilizing the code, right? So I'm here. I say my person says hello. I said let person is equal to new Tom person. I probably can decouple this and put part of it inside my start, because I want to do my initialization here, right? Which means I want to determine what my person object is here. So I want to kind of do something like this, like let person here. And then, so here's where I declare it here. And in my start, I want to do this, where I kind of declare my objects. I want to do my object instantiation in my start class. This is my start method. So this is the right way to do it, maybe. Or actually, what happened? Yeah, that's it. So that's where I want to put it. And then I want to use it down here in my main method, person.saysHello, right? Because I declare it one place and I use another place. And the reason why I'm decoupling it is because in real life, you have a big application, you can declare stuff up here and use it down there, right? And that's what we're doing here. All right, so this kind of should work. But the problem that we have right now is that, first of all, person is any, and I don't know what the heck person is itself. It's type of person. And we have to attach this person.js file to the application. And the way to do that is in my index.html. It has to go, like we did before the app.js file, because it gets loaded before so we can see it, right? So we need another script tag. And inside my script tag, I'm going to say /scripts /objects and then person.js, right? All I'm doing is pointing to this particular file and loading it before I load my app.js. However, there's a problem, and I need you to tell me what the problem is, please. Okay? Can you see what the problem is right now? Maybe you don't see it, but take a look at this. Okay, so it says, cannot read property says hello, uncaught type error. Don't know what's happening here. What do I mean? What the heck is this says hello? It's an app.js 28. So person.saysHello. Why? And why this decoupling didn't work for me? Okay? Well, there's a couple things that are happening, right? We're determining that, first of all, we're saying let here, which is wrong. That's the main thing. That was a mistake. Because I'm declaring a local variable that's overriding the global, the local variable of this scope. Let's try this out. And probably that's going to work now. Yeah, there we go. That's hello. Okay? So that's the first thing. So it works, right? Everything works as possible. But here's the problem. On my console, remember we're talking a little bit about security here, right? Well, now I have the person class, right? Available to me anywhere I want, outside, exposed to my console. Maybe I don't want that, right? Maybe I want to be able to package it inside of a namespace. I don't have to. I mean, this is still kind of a closure of its own, right? But a lot of times what we want to do is kind of do some information hiding. We want to encapsulate this in a namespace. And so we use namespace notation or module notation that I showed you before, right? Which means I got to go up to this object person, this thing here, and wrap it in another closure. And we're going to call this closure objects. Yeah, don't get mad, all right? I know people are like, what the heck? Why are we doing this? Because I'm creating this objects. I want to have an objects namespace that I want to attach a bunch of classes to, not just one class, but many, many classes. Because otherwise, imagine if I had a bunch of classes and I had just to remember them all. Where if I typed my namespace, I can say namespace dot, and then all the classes would appear. That's better than I have to know what class it is. Person, student, teacher, whatever. Can't do it that way, right? As easily. So what I want to do is wrap it up. So just like we did before, my first one, I want to say let objects. Because objects is going to be called the namespace. That's the namespace that I'm going to be using. So this is the objects namespace or module. Call it whatever you like. Okay. Then we need we need an IFI, right? Just like we've done before. So we need this function, right, where we do this kind of stuff, and we have this IFI. Okay. I'm just going to put it out here for now. And inside the bottom, inside this space right here is where my class is going to sit. Okay. But I want to do this return stuff that we did before. So I'm going to say something like, objects is going to be passing in here, right? Inside this space. And then I'm going to say objects or objects is equal to this. Oops. So that's what this does as it passes back out again, this notation. And somewhere in there, I want to say something like objects dot person is equal to person. I want to be able to do that, okay? Because this is going to return person back out. But we don't have person out. It's out here. So I want to take all this stuff and put it inside here. So now we have an IFI on the outside. We have an IFI on the inside for the person class, because this is the person class, capital P. And in fact, if I want to do the constructor, I can use document this to do that. So I can use this. Oops. La, la, la. Try that again. And document this. And what it does is it says this. Document this actually tells me that there's two things. I got a parameter that's a name and a parameter that's an age. And I can actually configure this parameter and tell document what is it. So it's a string, and my age is a number. This is just documentation. That's all this is. It tells when I use my class, it'll give me code hinting, right? Because I'm making a custom class. It'll tell the user how to use my class. I'm creating an API, right? An application programming interface right now from my class. I'm starting my API documentation. This is how we do it, right? And I'm going to basically say that creates an object of type person. Okay? We require these two things, and also that's how this instantiates. If I can, and then that's one thing. And now I want to add the same thing for my method. I can do the same thing for my method, right? Where I can say that was really bad. I don't know what happened there. It must be my entry. What did I do here? Oh yeah, here. Let's try that again. Document this. And what the heck did it do? That's a weird thing. Document this didn't like that. Let's just do it by hand. So I'm going to do it by hand. And what I can do by hand is say something like this. Because even if you don't have document this, if you use this syntax, right, it'll actually show up when the user uses the method. All right. And I'll show you that in a second. Just give me a sec while I type it. So this method outputs the underscore name property and says hello. So it does, right? And what does it take? I can add param. At param, I have nothing, right? There's no parameters. It takes no parameters, right? And I can say at returns void, which is what it returns. It doesn't return anything. Okay. So why am I documenting this way? Because just like we did when we made our own type definition library for our stuff before, right? This kind of does my type definitions for me. I can see this says hello stuff when I'm typing, hopefully. So how does this work? Well, now my app.js doesn't work properly anymore, right? Because person is okay, but down here, person doesn't make any sense, right? It's got to be objects.person. So objects.person, right? Objects.person. And it can't be person says hello is okay, right? Says a person that says hello is going to work, right? And it doesn't give me any code hinting right now because of the way it works out. But that documentation that I put up before, like this stuff in the other file and this person.js file, it's not showing up because of we're using modules and we're not actually defining the type definition, which we've done before. But for now, think of it this way. All I'm doing here is for the user. So if you looked at this and you're using my class, person, you could look at my documentation and go, all right, so this constructor, right? So you can say you can call it the constructor method, right? And then you can actually put it on 2 lines too, like this. Creates an object of type person, right? And then what are the parameters? A name and age. That's what I'm taking in, name and age. And you can see that down in here, it actually shows up when I'm creating when I'm defining it, name and age. And I can see that name now is a string and age is a number. And automatically, you can see that person.underscore name is a string and person.underscore age is a number. And that's what this stands for. That this keyword really refers to the object itself. So this keyword refers to this object that I'm defining, which is a prototype. And I'm attaching says hello as a method to the prototype. That's all I'm doing. I'm enclosing it inside of another object called objects, right? That's what I'm doing. And I'm returning it out here. Okay, so if everything worked out correctly, if I go back out here, I wouldn't have this error. So it says objects.person is not a constructor. So again, what we want to try and do is try and figure out, you know, the syntax. And I may have forgotten something, but notice that it says let objects is up here, right? I'm attaching it here. So my objects, my person object is up here. And then I'm using it. Whenever I get that error, objects dot whatever, or this is not a constructor, somehow it means that I'm not returning it properly. I'm not returning it out into the global namespace. So my objects, for whatever reason, doesn't return out somehow. And that's why I'm getting it. I'm getting this on line 16, right? So it says person is equal to new objects.person. Objects.person. And that doesn't compute somehow in my main file. That's the error that I'm getting. All right? So how do I check this? How do I fix it? How does this work? You know, because this isn't working. I'm not getting any code hinting. And this is sitting, by the way, inside my start method, or my start function, inside of this iffy, right? And I should have access to it because this function is happening after the iffy. And if you're confused, you can always try it out here, right? So let's suppose I was going to do the same thing. I'll create a module. So this is back in TypeScript. So I can go module. We'll call it objects, right? And I'll take this class, and I'll take it out, and I'll put it inside the module. And you can see that it does everything that I did. Oh, that's what I did wrong. I already know what I did wrong because I saw it. See this? Look. Instead of 2, I used 1. I knew I was doing something wrong the whole time. That's a problem, right? Because or one single pipe and 2 pipes are totally different. 1 pipe means I want to do a bitwise OR operation, where 2 pipes mean or, one or the other, right? Yeah, that was a real issue. I didn't even catch that. That's good. That's a really good thing. That's why, you know, I have a checker like that. So that's what this is. That's what this problem is right here. Okay, so that's all I need to do. And that should be fine. And let's just check this out now in my code to see if it's okay. So if I go to console, we should be okay now, right? But let's continue with this thing. I didn't really finish it. This is incorrect, right? Because there's one part that's missing. And the reason why this isn't showing everything here in my example is because I need to use the exports keyword. And once I do that, now I have a return person, right? Export. I return person, and now object.person is equal to person is down here. I didn't have that before. If I don't put the export keyword in there, right, then that's gone. It doesn't. If I don't export it, it's inside of the closure. Okay. So the closure gives us a couple of things. The module gives an ability for us to hide classes like we did before, and the other examples earlier in the semester, where I hid functions that are only for that particular object, that module, that are utility functions, let's say. I don't want to expose my utility functions or helper functions, right, to the entire world. I only want to expose them to the classes, right, that I want that might use them, right? So I put them inside that closure, right? But if I want to expose them, and just in this case, just use the export keyword in TypeScript, I can see that this is the case here, okay? Now, I like this in TypeScript better than Babel REPL. And remember, we talked about Babel REPL as well. So if I go Babel REPL, and I try to kind of do the same syntax in the modern syntax, modern way of doing it, I have this. So constructor, and then here's my all this extra stuff. And this is what Babel REPL does. But I want to tell you that this is a shim, if you will, right? And what it does is it works so that it works in any version of ECMAScript. This is not just targeting ECMAScript 5, but earlier versions. This is a little bit more compatible with what I'm doing. And that's why Babel REPL converts it to this. If I make this into a module, and Babel REPL unfortunately does not have module syntax, right? So I mean, there is no module for ECMAScript 6. Remember I told you there's some stuff missing from JavaScript 6, right? I have to actually do it manually. So I still have to do that closure. I still have to do, let objects, right, as an example. And then I have to do that closure around everything like this. So I still got to do this whole closure stuff, right? So function, and then kind of the self-executing function, and then pass in objects, just like we've done before. And then just as this thing, I know I forgot something when I did this. Objects, or learning for me too. And then objects is equal to object. Yeah, this is cool. And then I want to take this whole class, right, and cut it out here and put it inside here, right? And I want to expose it by using the objects object, and then say person is equal to person, right? I want to do that here. And notice on the right what it does. It does everything that I've done, right? Here's the person.prototype, but it adds a bunch of other little syntactic sugar, if you will, syntax up here. And where it says something like function class call check instance of constructor, and this is Babel. So it's going to convert this to the most compatible code, which is this. Myself, I think the playground is better on this side. This is where I like, that's why I'm saying this is a little better, a little cleaner. This will still work everywhere. It'll still work at every ECMAScript 5 iteration implementation. Where it gets funky is when we do inheritance, and which is what I'm going to handle next. I'm still using old syntax. And I'm using old syntax before I go to the new syntax because I need you guys to know the old syntax. The new syntax is not good enough. You need to know what's happening in the back end, right? Like I said. So far what we've done is we've made our person, and this, by the way, if you did just this, it satisfies my lab 7, all right, without inheritance. Okay, I didn't ask you for inheritance from lab 7. I just said just do OOP, very simple class, person class, and this kind of stuff. And you did another file, this would be satisfactory, okay? But what I want to do is actually define a person.ts file, okay? That's what I want to do. So I wanted two things. I want to make a type definition library for person. So person.d.ts, the D stands for definition, right? And my person is going to be the same name as my person.js. So here's my person.js. Person.js is this. Person.d.ts is going to have my type definition, right, for this. That's all it's doing. So it's going to give me some code hinting when I'm using it in my app.js, like we've done before, right? And now I can take away some of this comments, right? So I can take these comments away for now. And I'm going to show you how it looks a little cleaner, right? So here's my comments. All right, so now we have no comments inside my person class except for it says person class. Yay. But here in my person.d.ts, I can actually declare what I want. Like, remember what we did before? We declared a module called objects, right? That's the first thing we do in my module. I can use the declare keyword. This is TypeScript now that I'm teaching you at the same time, just to give you some flavor about how to declare your objects, right? And inside there, I can make a class. I want to export my class, which is person, right? And inside my person class, I'm going to have a constructor, right? And my constructor is going to take a name, which is a string, and a age, which is a number, right? The constructor. And this, I can say, I can use document this on this, no problem, right? Because it understands TypeScript nicely, right? Does all of it for you, right? And then at the bottom, I can do my method, right? Which we didn't have before. So my method was called says hello. So it says hello, right? Which returns void. Okay. Nope, I don't define it. I just declare it. Right? My method that says hello. And then I just type in another thing here, or document this. It says member of person. Now, the one thing I want to say, because all this is member of person, I really don't like this part. It's not a great definition. I don't use member of. And we'll point to this in a second. I'll tell you where I got all this, what param means, and all this stuff. Yes?
So signatures in JavaScript, they are closed in feature.
Kind of, Yes.
Like, for example, we are making this, using this void, the colon, in C# instead.
This void with a colon is only TypeScript. It has nothing to do with JavaScript. JavaScript and TypeScript are two different languages, right? I'm using TypeScript to help us. So when we use my JavaScript class, it gives us code hinting. That's it.
So can we say like void, say hello?
No. No. So if I say this method, like again, outputs underscore name to the and says hello to the console. That's all it does, right? And one other thing I want to put in is that at returns void, and I want to do this void. Okay, and the curly braces means type, right? So I save this person.d.ts, right? It's next to the person.js. Okay, it's inside my objects, and then inside my app.js, I'm hoping that if I hover over a person, it'll give me code hinting. Now it doesn't, because remember sometimes we have to close my I have to kind of close down my Visual Studio Code and reopen it, because then it understands the type definition. But that's what this type definition does. It's the only reason why we use it is to help us with code hinting, okay, with JavaScript. But this person.js is perfect. It's a person class with a simple method. And now we want to talk about inheritance. Okay. Let's use another class to inherit from. We'll make a class student, okay? And I want to show you how to do inheritance with the way we do it now, okay? So how do I do inheritance? I'm going to do it first inside my app.js, and then I'll remove it and put it in its own file, okay? This is not part of your lab. This is extra. Okay, your lab, everything I've done today, your lab is done. If you look at lab 7, OOP, this is it. You don't need anything else other than this for your lab. You just do this part and make it work. But this part is the next part that we need to go. We need to do a little bit of inheritance, because what's the use of classes if we can't use them and inherit from them, right? At the end of the day anyway. And you might say, well, classes are bad, inheritance is bad. We talked about that yesterday. There's bads and goods about using inheritance, the whole domino effect that you can get with inheritance and so on. But let's suppose I want to make another class. So let's do it up here inside I'm going to do it inside of my app.js for now, and then we'll extract it later. So just like we did before, I want to create a closure. So I'm going to say let student, right, equal to this closure, right? And guys, you should be very familiar with this closure now, right? And then inside of there, we're going to say function student, right? And I'm going to take 2 parameters for the student, and 3 parameters. I'm going to take that my first parameter is going to be the name, and I'm going to have age, and I'm going to say this dot name is equal to name. Actually, we'll put underscore. So this is just defining a new class, right? And this dot age is equal to age. And what else do we need a student? Maybe a student ID. That's something different. So student ID, right? And we'll say that this dot underscore student ID is equal to student ID, right? And maybe we'll have another little method, right? Which we're going to call studies, right? Again, we can use inside here, we can use the student.prototype. So student.prototype.studies, right, is equal to a new function, right? All the same stuff. That's how we write classes in JavaScript, right? So far, we haven't inherited anything, by the way. We're making new studties. Wow. We're making new classes, right? And we can say a console.log, backtick, whatever the student name is, this dot underscore name is studying, right? Exclamation mark, because I like exclamation marks. Yes.
Can you use double quotes instead of backtick?
Nope.
No.
Backtick interpolates. Double quotes does not. You'd have to use the plus in this way. You can use double quotes, but you have to use concatenation instead of interpolation.
C# we do. JavaScript.
No, in C# you could do this too. Because C# also has new template strings in C# as well. If you look it up, it's brand new. But it's instead of dollar sign, I believe it's $/. We'll see it. So yeah, so this is what this does. We're good, but this just makes a new student. And my student, unfortunately, does not inherit from anything. Okay, so how do we do that? How do I, because this just makes a brand new class, and this is duplication. I'm duplicating this part, right? And, you know, I don't have access to the other method. I want the other method, it says hello. I want my student to be able to say hello too, right? That's part of it. Otherwise, the student can only study, can't say hello, right? That's not good. So how do we do this? Well, we do it like, kind of like this. We say, well, okay, I want to access the person class, right? So I want to kind of do person, and it's not, of course, person, it's objects top person, right? Right? And I want to do this, I want to call the superclass itself. And just to give you some examples of this online, so before I go too much further, here's the inheritance part. This is the document that I actually also installed for you, so you can see it in up online. You can see that we have a person class. This is exactly the example. And in this particular case, actually, they have another object. This is an example of composition. I have another object that just has a name. It's a name class. The name class has two properties, first and last name, right? In this case, they're just empty properties, right? And I also have an age and a gender and interests, right? So that's the person in this case. And their constructor has first and last name, age, gender, and interests, right? And I say person.prototype greeting, instead of says hello, is equal to the same thing, alert, hi, and this is your syntax. You're concatenating. You can use double quotes or single quotes here. Hi, I'm so-and-so plus whatever. Okay, cool, and that's the class. But now I want to define the teacher constructor, right? So now what I say is person.call. I pass in this, and then I pass in first, last, age, gender, and interest. But notice that I don't pass in the subject, because subject does not compute for person, only computes for teacher. Well, let's do the same thing. So person.call, we're going to talk about what this call method does. It actually calls the function. That's what it does. So I'm calling the superclass is what I'm doing, okay? So I'm saying person.call, and I'm passing a name and age, but not student ID, and I'm also passing in a reference to this new structure. So I'm passing in all this stuff. So what this does is says, hey, call the person's super constructor and pass in name and age. So I'm actually forming up a new object, okay? That's the first part. This student ID is unique to the student. It doesn't exist in person, but we need to use person.call to call the superclass constructor. And this studies is okay because I'm attaching it just like we normally did, okay? We're missing one thing. And if you scroll down, you can see that I've got my teacher and la la la, and this is I can do this like this, but now, like it says here, what I'm doing is I'm duplicating, right? So we don't want to duplicate. So person.call, brick.call, in this particular case, there's an example of a brick, and now I have a bluegrass brick, different kind of brick. Here's my different kind of brick, and the brick we call this. We just pass in something with no parameters. If I don't have any parameters, I just can call the super constructor and pass in this, which is a reference to the new class, my child class. And this, my friends, is what we can do. We can say that the teacher.prototype is equal to the object.create. Remember we did object.create, and we said object.create null, and object.create created an empty object. But I can also we can use create to inherit from another object. And remember, what I'm actually saying is I'm realigning the prototype. I'm saying, hey, don't use the object prototype, my super duper object. Don't use that as the prototype for my teacher in this case. Use the person prototype as my prototype. It's just repointing my prototype. That's what it's doing. It's not inheritance like we know in classical inheritance. So I have a prototype. It's the object superclass that exists. Yeah, it's already there, automatic for all JavaScript. By default, if I create an object, it points to that. And I'm saying, hey, don't point over there, point over here. I want you to point to this one. That's what this is doing. So what I need to do is, so in here, so first this is inside my student object, right? Which I'm going to return, by the way, right? Because I haven't returned anything. I'm going to return at the end, student. That's what I'm going to do. So when I say this, student is equal to this. But the prototype that I want to do, and again, it can be done anytime I want, but probably before this one, is I want to do something like this. I want to say student prototype is equal to object create, and then I want to point to the prototype that I want to point to, which is objects.person. Objects.person is my superclass, and I'm saying here that I want to point my prototype, right? The prototype of the new object I'm creating to the person class, which really is, hey, extend or I want to include, this extends the person class. That's what I'm doing. Or inherit from, that's what this means, inherit from the person class. So give me all the stuff that the person class has, plus I want to add all this other stuff. Because remember, whenever I make subclasses, they're always bigger than the parent class because they include everything that the parent has, plus I add more stuff.
So we can exclude something?
No. Not officially. And you don't do that in C# either. You don't sit there and go, I don't want this one, and I don't want this one, I don't want this one. If I inherit from a class in C#, I inherit all of it, right? That's why inheritance is bad.
I think we can
Only private and public. Private means you can't, it's still there. It's still part of the whole package, but those methods and properties are hidden. But they're still there. Once you call the super constructor, you have that whole object in C# as well, and Java. You just can't access the methods or the members, but they're there. It means that the subclass is actually fatter every single time. Whenever you inherit, and that's another bad thing about inheritance, your inherited classes, the ones that are the derived classes, the child classes, whatever you want to call them, are always bigger, always, than the parent. Okay? Yes?
Yeah, use this keyword this.
Yes.
You say objects are person, well,
yes. So this passes my, when I use call, the call method, which we're going to go back, because call actually exists on functions. It's a function call. I can actually pass in a reference to where I'm physically at. It's an option. And then pass my parameters, right? And we're going to get there. And so I'm going to go back and review that because we didn't cover that when we did functions because that is just, there's call and also there's another one called apply. There's two, call and apply. And they do very similar things. And we're going to see what they do. But this is the syntax that you need, right, for it to work. So there's my student class, right? So return my student. And now let's just save it, first of all, before we use it. And let's see if we've got an error, because that's the first thing I check. So no error so far. Yay. Now, inside my start method, right, I'm going to, so because I've got a person, let's make a student, lowercase. Here's a student, right? And inside my start method, I want to do this, right? Just like we did before. I want to say that, well, my student is equal to a new student, right? And my student needs name, age, and student ID, right? As you can see. So name, so we'll call him, or we'll make a girl this time, Carol, random name, and age 25 or 20, let's say, nice and young. And student ID, I don't know, 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. Okay. And that's the student ID. Yeah, great. And now I want the student to studies, right? I want to be able to do that, student studies. But I also want the student to says hello, right? And that's the test. Does it inherit the says hello? And do I pass in the name and all that stuff? Because I never declared name or age as an object, as a property of the student class. I didn't apply them. I'm using the person class, I'm calling the person class to inherit those two properties. And I never declared says hello in my student. It's part of my person class, like you normally would expect. So this should give us exactly what we think it should give us. But I want to do this in my implementation, which is here. I want to do that in main because I want to be difficult. That's the kind of guy that I am. I want to try to do the hard way. Let's output what student looks like too. Here's what student is. And yeah, we got an error. But look at this. Carol is studying. But student that says hello, whoa, that's not a function. Okay, but that's interesting. So we got most of it. But something is missing. Because look, here's my student. And then da-da-da, right? And then it says age is 20 and Carol name age got transferred over, right? But one thing that was missing somehow in my prototype, if I go to my prototype, it looks like the person is the prototype for student, right? Here it is. And person says hello. There it is. So what did I do wrong? Here it says hello. It's the same, right? I should be able to reference it. How come I can't? Now, I should be able to do that, right? So that's the problem. That's the first problem. But this is something that we can look at. So let's take a look at this. So here's an example of what it did here on the documentation. Teacher.prototype constructor is equal to teacher. It says this can be a problem, so we can set this right. All right, now it says because after adding the last line, teacher.prototype's constructor property is now equal to person, because we just set teacher.prototype to refer to the person, right? And to reference an object that inherits properties from person.prototype, saving your code, loading this page, and you're going to have a problem, right? It could have a problem, and this is what it does. It kind of adds this line of code here to fix it. And we want to do this new greetings function because teacher.prototype.greeting is this overrides. In this particular case, it's showing you how you can override a function by just redeclaring it, right? Because it'll override the one that's done before because that function is the one that's part of the prototype and so on. But I want to be able to use the old prototype, not the new one. So why isn't it coming up, right? So it could be a matter of declaration, right? Notice we did this, object.create, object.person, that's student.prototype. And then what it's suggesting is do a student.prototype.constructor is equal to student, right? That's what it's telling you to do because that'll fix the problem. And then we're adding a studies function, right? And this works, no problem. And we should be able to inherit the person. Objects.person is what the prototype is. We should be able to get there, right? But I don't want to do like student.person that says hello. I don't want to do that. We want to say says hello should be a part of our function, right? So let's see if that works differently now. It probably does not because I think I'm missing something. So Carol is still studying. We see that we have a person and it says hello and students. Here's my student with a number and all that stuff. And we still have the student constructor, age, name, and student ID. There's my constructor, my student, and it has studies. Yeah, all good. And then I'm trying to attach a prototype. You see the person. So prototype function is the person. When I did that whole thing, it messed me up, actually. Let's just undo that. So see the change? That's better. So proto function person. That's what it should be, like this. And person has this. What about if we did this here? Does this help us? Because sometimes it's declaration syntax, right? I'm saying studies, and then I want to extend it. Now, studies is not a function. Take a look. I'm pointing this out because you guys need to know, right? that this is how it's working, right? So studies is a function, object.create, object.person. Once I've done this, then studies is wiped out because my prototype is gone, right? My prototype is gone. If I did this prototype, I'm actually not extending my prototype anymore. I'm saying, hey, declare my prototype as this, and then overwrite it. That's what's happening here. This overwrites this. So when I declare my studies and I do this, it just overwrites it with the person. Okay, all right. But then how come, just putting it out there, how come I can't do says hello, right? Student.says hello. I can do person.says hello because student is of type of person, so we think, but it's not true. All we're doing is repointing my prototype to something else. I could do it the tricky way, the long way, and say something like, let's put it back the other way around. I could do something like student dot says hello, right? Sorry, dot prototype dot says hello is equal to, again, I could say my person, right? Dot says hello. I could do that. Objects dot person, sorry, objects dot person dot says hello. I could do that. And that might be a tricky way of saying that, well, my says hello function is actually this, right? I could do that. And that would do what you're saying. I could expose or hide, but that would be a weird thing. And as you can see, student.says hello is not a function, right? Because objects.person says hello, right? And if I go in there, objects.person, person uses constructor syntax. So because this has never been declared, doesn't make any sense. I can't also do this. I can't say this anymore. This dot says hello because says hello doesn't exist. It doesn't exist. So this also would error out. It says hello. Student dot says hello is not a function, right? I could redeclare it, but that kind of disagrees with my the whole idea. I could do this and just redeclare it, right? So as whatever console.log. I could do this whole thing again and say. But that kind of goes against inheritance. This dot underscore name, right, says hello. Do that. Okay. And then we're good. Okay. But this is the problem. The problem is, how do I inherit from methods from a class? And if you looked it up, if we having I'm having a problem. I'm probably forgetting something. So if I say inherit function JavaScript, and this is I'm probably missing something in this thing. It's the same article, I'm sure. But here's my function. Here's my prototype B, right, and so on. And there's an article in here that I probably can. And here's inheriting methods. This is what I wanted. So object.create O. P is the new object. Here's my first object with the function that's called M, right? In this particular case, it's an ugly name, sorry. And if I say O.M, it actually does the function, right? No problem. And then I make a new object P, which extends O. This is the original object, extends it. That's what this does. And then if I say P.A, creates a property A, right? This is good. But if I go P.M, that's okay. It works, right? Everything here is the same, right? Object.create. Okay, that's what we're doing here. So the other way to do it, instead of doing it this way, is we create the object first, right? I'm just pointing it out there, right? Instead of doing it this syntax, we can say that this object.create person is in fact the object, right? So we say that student is an object of type person, right? Instead of student.prototype, right? And we would do that like further up the chain, like up here. Like I say that let student, instead of this syntax, I do is equal to object.person, and then I have the other stuff, but then I don't have my own constructor. That's the problem. And that's what this doesn't show. This doesn't show constructor syntax. So with the constructor, here we go. So here's my graph, and graph.prototype is equal to add vertex. Notice that I have a, is a function, right? Add vertex is actually a new function, a method that's added into the graph class. That's what it is. It's another way of doing it. Okay. So, and then we can say that G is an object of type graph in this particular case. So G is equal to new graph. And then if I do object.create, so here's A is an object, B is I inherit from A. That's one way of doing it. Okay. And you can see that we tried this idea of creating an empty object. Okay. And here's where I want to go to. This is the new syntax because, we're having trouble. So how do I use the new syntax to inherit? I'm going to mix the new syntax with the old syntax. And I'm going to do that in a separate file. And then next week when we come back, not the next week because we're off next week, but the week after, I'm going to continue with object-oriented stuff to show you how to do this properly because we need more time. Yeah.
So this syntax is
the new syntax, and it works with, it's pure JavaScript, and it works with 89% of all browsers. Let's say, right? So let's do the new syntax for the student class. So I like this, but instead of all this objects.create, and this is the way you would do it, and we're having all this trouble, I'm just going to comment this out. So this is the old way, and it should work actually. I'm just missing something. And I'm going to kick myself because I'm going to go home and I'm going to go, let's show them this instead. It's some like double pipe or equivalent or whatever. Or the order that I'm doing it in or something like that. Okay? But this is the old way. But the new way is what I want to do is I want to mix it up. So I'm going to kind of go into my a new object, make a new file, right? That we'll call student.js. Here it is. And we'll say that it's inside the module objects. So we'll say we'll do a closure, right? Where we pass in objects, right? And there's the closure. And the object, of course, is going to return objects, or I'm laughing about that. Objects is equal to this. I know, it's crazy. And then I can use my new syntax. This is the new syntax for ES6, which is far easier. Class. Use the class keyword, and then student, and then we use this beautiful thing called extends, right? And it's objects.person, right? And once we've done this, class student extends objects.person inside this closure, then we can say that in the constructor, right, we want to pass in name, age, and student ID. We want to call the super constructor, which is the objects.person super constructor, which we're going to pass in name and age. Nice and easy, right? And then what we can do is inside here, we can create a method called studies. This is legit. This is like ES6, okay? And console.log. I know we're running out of time, sorry. $, this _name. I was not picking it up because it's in a different file, but that's okay. And is studying, right? There it is. And now on the bottom here, we can say that objects.student is equal to student, right? Which passes student back out inside of the namespace, okay? But this, my friends, is the new syntax, which is far easier than the old syntax, right? And it's totally fine. If you were to do this for your lab instead of the old syntax, okay, right? Let's take this. And now, of course, in terms of using this, I can't use it until I include it. And it's got to be included after person because it depends on person. So I'm going to do that. So I'm going to say script. So I got to include it in my script or else it doesn't compute. So scripts, objects, and now it's student. I got to include that because person is the superclass and student is the subclass. Okay? So in order for to make that work, let's make sure that I've got it right. It can't be student anymore. It's got to be objects.student because it's inside my objects module, right? And I think the rest is okay. And if I did everything right, we'll see the error. If we get an error, we'll see the error. So go back out here, and we're good. Nice and easy, too. Now let's take a look at student now. Student inherits from person. There's the prototype. See, that's what I wanted. I wasn't getting that. Student inherits from person, right? Before we were getting something else, right? And then inside my prototype, you can see that I have studies, right? And inside that's in my person prototype, I have studies. But I also have in my constructor for student, I also pass in my person constructor, which also leads us to my constructor, which includes the other one, which includes the person constructor, which also includes the says hello function right down there. So the rabbit hole, as I like to call it, right? It's all in there. But that's way simpler syntax, and that's why we move with ECMAScript 6. We're moving to that simpler syntax. And it, like you see, it works in Chrome, no problem. I didn't do any Babel or transpiling or anything, right? But remember, it only works for ECMAScript 5 and ECMAScript 6. So Chrome, the latest version of Chrome, works with some ECMAScript 6. What I'm using here is ECMAScript 6, the latest version of Chrome. All right, so now this is how simple it is, how beautiful it is. And it makes sense, right? This makes much more sense to us as using C# and Java than if we're using, if we're learning JavaScript for the first time. But you need to know the other syntax because otherwise, you're no good. If you don't know, you're not in JavaScript. And I'm forgetting something with the old syntax for sure. Just one more note before you guys go. If I was going to do the student subclass here, it would look different, far different in TypeScript. So I would do a student subclass. I would say, so let's just do it inside of the objects container. The way it would look is, I have an extra curly brace in there. Curly, no. I would make another class, export class, which is student, right? Which extends. We use the same keyword. That's why TypeScript is so cool, because it extends the same functionality that we're going to get inside of the latest version of ECMAScript 6. We use a constructor, which is name, age, and student ID, like before. And this time we call the superclass and pass in name and age, which satisfies the constructor requirements, right? But we also have to do this dot student ID, or student ID as an example is equal to student ID. We have to still do that, right? And they're waiting. And we still have to define student ID out here as a string, let's say, which would satisfy nothing, it looks like. But yeah, but that's how you would still define it, just like we're defining it here, right? So how we have private, and we'll make that private. Oh, there is no underscore. That's why. Yay, I'll be okay, because I'll put private here. And then we can define the same method. If you look on the right, that's what I want you to look at. Public studies. And now you can do a console log, whatever, right? But if you look at the console log, I'm not going to finish it because we're running out of time. But if you notice here, it adds this convenience method that I've got to point out to you in TypeScript. And that's why I didn't want to use TypeScript in this case, because this extends for it to be absolutely compatible with ECMAScript 5. Two ways to do it. If you want absolute compatibility, Babel, or using TypeScript and transpiling. We're not transpiling. We're using the latest version of Chrome or Firefox or whatever. We'll accept class. It's okay, right? But some older versions of browsers, it looks at the class and it'll just error out. Just FYI, just letting you know that. So here's the extend. This convenience function takes care of the extending piece, because if you notice when I go to student, it says student extends. We have this little function that's being called that extends and does all the work for us. And the super call takes care of that whole prototype chain fixing, which I forgot to do. All right. Questions around object-oriented programming. So really, I just scratched the surface, guys. Like I'm telling you, I know you're thinking this is crazy for scratching the surface, but that's what it is. What I've showed you today is the bare minimum that you need to know to make objects and you know, to make your own classes in JavaScript. There's a lot of stuff we didn't have a chance to cover, which is in the PowerPoint, which I will cover with you guys when we come back, because we have to use somebody else's classes too, and I got to talk about that a little bit. So bear with me. Stay tuned for the next time when we go back. I'll do the PowerPoint from this week plus PowerPoint from next week. Next time we get together, it won't be that bad because we won't have to go through all this. All right. Otherwise, please do your lab. Lab 7 is due tonight at midnight, officially. So get her done, and then we'll see you guys in a week or 2 weeks. All right. Thanks so much.